Okay, the recording is started. So we'll see OSI layers. First of all, what is OSI? Open System Interconnect, and it is also called as 7-layer model. 7-layer model. Open System Interconnect. It is 7-layer model. So 7 layers are there. It is also called as reference model. Reference layers. What is a reference? Reference means just for understanding. Reference means it is for understanding of network function. How network is going on, what is the client, what is the server, what is your request, how you are sending, how you are receiving, if there is any issue, also how to, like this. So understanding and defining of network. Okay, you can say define and understanding of network, and very useful for troubleshooting network. Lot of people, means not lot of people, like a OSI layers. So usually in CSE, IT, ECE background people are having a subject in the network OSI layers. They are studying it, and of course, when you join any networking related courses, OSI layers are there. But there is some misconceptions is that like OSI layers, from OSI layers, all other topologies are all other things are came up. Now nothing. Earlier, already DoD model, TCP/IP model, IPS, SPX models are there, already there. OSI layer is understanding networking models, understanding existing networking models, troubleshooting the any existing networking models. It's a common platform. It is a open source type. Okay, and in even some of when I went to certain trainings, so there people are telling like this: OSI layers are used by very big organization, not by small organization or a normal organizations or a public organizations. It is only specific group of organization or research committees we use the OSI layer. It is wrong, completely wrong, guys. OSI layer for understanding and troubleshooting, and you want to build a new network, so OSI layers are very useful. You want to troubleshoot, OSI layers are very useful. Okay, so that is the main point of your OSI layer. And there's a certain organizations also come up, like make this one as a standard one. So one is a ISO standardized this OSI model. ISO is an organization. ISO is an organization which standardize OSI model. Okay, it's standardize the models, but it is ISO standardize the OSI model. So ISO means international. Anyone? International
Station organization.
Very good. Standardize. So it's a little confused. Standardization. This is always confused. One is correct. Standardization. Yeah, both are same. Okay. International Organization for Standardization. ISO. International Organization for Standardization. Organization for Standardization. Okay. OSI model is standardized. One more journal is there. IEEE given a journal. So anyone?
Institute of Electrical and Electronics Engineering.
Very good. Institute of Electrical and Electronics. Engineering. It is nothing but an institute. It's an organization institute. You know, we do engineering projects. So like a IEEE projects means it is a lot of journals will be released from the IEEE. Some people are try to prove in a practically. Are like that. Okay. So IEEE is also journal. So there is so many other things. Okay. Internet Task Force. Okay. Internet Task Force, IANA, ICANN. So these are different organizations are there. Internet Task Force, numbering assigning IP addresses assigned by like this. DNS maintained by ICANN. Okay, so just search in a Google each one, each and everything. Okay, like IANA. So what is IANA? What is use of IANA? Like that you can see. See, this is IEEE. This is IANA, Internet Assigned Number Authority. ICANN also engineering, Internet Engineering Task Force. So I miss E. Okay. Internet Society. Internet Society. This is Internet Society. This is ICANN. ICANN. So find it. What is ICANN? Internet Corporation for Assigned Names and Numbers. Okay. So there is a different type of. That's why I got it out. Internet Engineering Task Force. IANA, ICANN. So find it all this kind of stuff. Whole network standard number is like this. IEEE 802. It is a your whole network. What are the network we are using now? That the standard number is 802. 802. Okay. For example, guys, 802.3. When you see like this, when you see 802.3, meaning is it is Ethernet. Your regular Ethernet, fast Ethernet, wide Ethernets are there now. That is a Ethernet. If you see 802.11, so guys, anyone see 802.11? When you buy a mobile phone, laptops, internet connections, anyone see 802.11? Wi-Fi adapters, Wi-Fi related, Ethernet, Wi-Fi related, Wi-Fi routers, Wi-Fi things. Okay, so when you see like this or like this, it means it is a networking related. It will be changed like this. So this represent some devices, some protocol, some wire, or like that. So different type of standards are there. Okay.
These all are layers of OSI.
No. So it's about a voice only. A layers I didn't start it. Okay. So about a voice, when voice come up, so all these things will be come up. Like this is about exactly voice layer. This is other organizations which standardize this model, like to understand the other organization names, their role in the networking, their role in the networking, numbering standards. Okay, so that's why I'm explaining. Very good. So very good. So that's the clarity we required. So this is not a layers of voice layer. Okay, so this is just an organization. These are different organizations and their names. What is the participation of this networking related one? This is control. These controls name and numbers. Name and numbers. Name and numbers means IP addresses, domain names. I can use google.com for myself, right? This is google.com and this is the youtube.com and this is some others.com. Okay, for example, amazon.in. Okay, who will regulate the names and the IP addresses. Okay, so these organizations, under this organization is regional internet registries will be there. Okay, so they will maintain this. Ours is this one, APNIC. Go to APNIC and then Asia specific region. So go to APNIC and find check your IP address. Like you want a public IP address, domain names like that. So it will be maintained. APNIC. Find what is APNIC also. Okay, like this. And these are the network related standards. Network related standards also there. So when you see 802.3, it means it is a Ethernet wide connection. 802.11, it is a Wi-Fi related thing. Okay, so that's the only thing. Now we'll go to OSI layers again. So layer by layer we'll write. Guys, these layers, some people write in a bottom to top, top to bottom, layer 1 to layer 7, layer 7 to layer 1. So whatever it is, same only. So it is first layer, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. No, it is a layer wise. We can say this is a layer 1. It's a layer 1. Layer 2, like this, bottom to top. So that's why in a certain textbooks or a certain slides or lectures will tell in a different ways. So I told from top to bottom, right? So application layer, presentation layer, like that. Some people will tell first physical layer, network layer, data link layer, network layer, transport, session, presentation, application. Guys, some of you already know the OSI layer and already you by hearted or learn in a certain way. So no problem. If you are studied from physical layer to application layer, you are trying to tell like that only, no problem, not at all a problem. Okay, so some are very like a very fixation mode people are there. Okay, like no, so I studied from like this, I should tell like this only. Some are study from bottom to top. No, first you have to tell 1 2 3 4. How can you tell 7 6 5? So that some people try to argue with that one. So no, not required. Do not interchange the layers. If you interchange the layer names, problem will occur, like a application layer, presentation layer, transport layer, data link layer, session layer, network layer, physical layer. First layer, last layer we can able to remember, and remaining will interchange it. So don't interchange the names. Either you tell application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, or physical layer, data link layer, network layer, transport layer, session layer, and presentation layer and net application layer. Any ways 1 to 7 or 7 to 1, anything is okay. So this is a layer 1, layer 2, layer 3. These three layers we call it as hardware layers. Okay, and the top first three is we call it as software layers or upper layers. Okay, these are software layers, these are hardware layers. Hardware devices are there. These are hardware devices are there. This is no hardware device. It is your system, your servers, your clients comes under this thing. So what about this transport layer? Transport layer has two more things, like it is Heart of OSI layer. Okay, Heart of OSI layer. It provides end-to-end connectivity. End-to-end connectivity. Okay, so this is about your main part of OSI layer. So what are the OSI layer, guys? Tell. No need to open the speakers. Sorry, mic, but just tell again. OSI layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Some of you already know from the bottom to top. So for you, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. It will take time to completely remember whenever suddenly some people ask question. So what are the layers of it? So it will take time, but no problem. Keep chanting it. You will be able to remember. Okay. For first time and second time, it may be a little bit harder. Third time, fourth time, fifth time, you can able to. So voice layer is also very important question. And also it is very important in the troubleshooting also. One by one, layer wise application. Okay. So one by one, I will explain. First one is application layer. It provide user interface, client applications. Okay. So like a client side. So how you apply the client side is the client up like a web browsers, like a Google Chrome. Web browser means Google Chrome, Microsoft Edge, Firefox browsers. Okay, filezilla is an example is FTP client. Filezillas. Putty is an application for a remote connection for a SSH or a telnet application. Okay, Outlook is a mail client, so you can communicate like a mail client application. So it's a client side applications. Server
So
application.
what, sir, what is mean by putty?
Putty is also an application. So you want to connect a remote PCs, you can connect it from Putty, like SSH protocol. There is a remote server. I want to connect with the SSH protocol, remote server IP address or a host name, SSH open. You want to connect with a telnet, for example, like this. Remote server name or IP address, port number, telnet, open. Like this, Putty is also an application by connecting remote servers. Very good. So what is a Putty? Putty is also an application for a remote connection using SSH and telnet. Outlook, guys, this is Outlook. Okay, I'm sending a mail and receiving a mails through Outlook. Okay, I can able to send a mail and I will receive a mail through this Outlook. So that is a Outlook mail client. So this is a comes under application. Provide user interface. Okay, user interactions. User interface means user interaction things, and client side applications, server side applications, or servers. Server or a server side application. So that's why I put a slash just for understanding. Server or a server side applications is like a web server, Apache, HTTP, server, tomcat server, okay, IIS, Microsoft IIS web servers. Okay, different type of web servers are there, right? So Glassfish, application server, web servers are there. Okay, FTP and vsftp servers are there. FTP server, FTP or vsftp servers. So SSH servers, Outlook mail servers like Microsoft Exchange, Zimbra mail server. Okay, a lot of mail servers are there, just for an example. Okay, mail servers like that. So server, client, server application, client applications. Okay, server side, server services, server applications, service kind of stuff, right? So like this, these are the different type of servers with a different type of applications or services at a server side. And a client side, access related, so either directly in application or a command prompt, whatever it is, client side applications. Okay, so application layer will take care of your, will try to understand is about your client side application and server side applications and protocols. What protocols you are using to access the service. Okay, what protocols you are using? Protocols using to access the service, requesting service or accessing the services. Like I want to send a mail, SMTP protocol. I want to receive a mail, POP3 or a IMAP protocol. I want to access a website, HTTP protocol. I want to upload or download a file, so FTP protocol. Okay, like that. So different type of protocols we use for a in a communication, right? So that will be in a application layer, and also client side, my application, server side, their application or a server. So these are comes under application layer. Okay, next, presentation layer. Presentation layer is quite easy to understand, guys. So when I open a data, so like when I open a website, for example, see there is a lot of pictures are there, text is there. Okay, sometimes it will, you know, GIF kind of stuff will be there, right? GIF kind of stuff will be there. Pictures are there, movies are there, like that, right? So data can be in anything. So what it will do, it converts data into ASCII format. So what data it is? So what data? So that is important, right? So what data it will convert into the ASCII format? Data is in HTML format or TXT text format or PDF format, DOC format, any data format, or it can be MP3 format, MP4 format, 3GP format, FLV format, WMA format, okay, GIF format, PNG format, JPG format. So data can be any format, but it converted to ASCII. Guys, anybody will tell what is ASCII?
American Standard Code for Information Interchange.
Very good. Information change. Okay. American Standard Code for Information Interchange. It is nothing. It is earlier in a intermediate and diploma. We keep studying what is ASCII, ASCII, ASCII. Nothing, guys. Each and every letter for every representation, including dots, spaces, underscores, everything has a numerical number in a hexadecimal format. Okay. for everything, A, B, C, D, E, F, G, H, or any pixel or anything, any icons, anything. There is a data related to ASCII format data is there, because from ASCII to binary direct exchange means our data, our language is high level language. Machine don't understand our language directly. So it should be convert into ASCII format for machine understanding language. Okay, so that's why it converts the data into ASCII format. So then it is directly converted into binary format. Data not sent directly, it is converted into binary format. To convert a binary format, so you, first of all, presentation layer convert our data into ASCII format. This is called encoding and decoding. This is called encoding and decoding, and also it will compress the data and decompress the data. Compress the data and decompress the data also. And one more important is it encrypt the data and de-encrypt the data. Decrypt. Compress the data. You are sending or receiving a data bigger one. So like you are sending a data size is big. Compress the data and send it. So then at the receiving side you will decompress the data. At receiving side you decompress the data. You are encrypting the data. Why you need to encrypt it, guys? This is very plain text format, right? So you can able to read the data what I am typing. But in encryption, normally users cannot understand what is it. For example, I put a word is like a password. This is just a plain text format. But same data while I'm sending through the network, the data is in different format. For example, it shows like this. Like this. So what happened? You cannot understand anything from this one, right? You cannot understand anything from it. So it's a complete pattern or a language is changed. Okay, look like something is gibberish is there. You don't understand what it is directly. Okay, so this is what we call it as a encryption. So this is directly plain text format, so we can view and we can understand what it is written. But this is an encrypted language using a key, using a certain key will encrypt the data. So this encrypting the data is cannot be catched by anyone. Okay, only for end-to-end encryption. It means I can view the data and the server has the data. I can view the data. In between the me and the server, data cannot be viewed by anyone. That's why it is possible like you are paying the amounts with the encrypting mode. Okay, we are paying amount, right? So you are paying your data transmission, payments, banking sectors, mail communications. We are using HTTPS site. If you see HTTPS means encryption. HTTP no encryption. See, look at here. HTTP site no encrypt. Data can be compromised. Anybody can able to tap your data and get it. HTTPS encryption encrypted, so data cannot be accessed by anything. The S means SSL. Okay, so you can secure socket layer SSL. Okay, that is SSL. Telnet and is no encryption, remote access without any encryption. SSH secure shell encryption. Okay, FTP no encryption. vsftp encrypted, very secure file transfer protocol. Okay, like that. So different type of protocols are there. Some are like see, telnet SSH, different protocols, same purpose but different protocols, different type of mechanism. But this is encryption, no encryption. But both are HTTP here, sir. It is also HTTP. This is HTTP. But this state HTTP plus SSL, HTTP plus SSL, then it is HMA encryption. Okay, like that. POP3, IMAP, SMTP. So these protocols use other encryption techniques and it encrypt the data. Usually SSH use RSA. So encryption hashing algorithms are RSA, SHA. You can get lot of them. So like what is RSA, SHA? Find it if you can able to do it. Okay. But my point is very simple. Guys, presentation layer, whatever the data convert into ASCII format. That is called encoding, decoding. Okay. Next one is it compress the data and decompress data. Compress, send, receive, decompress. While sending, encrypt. While receiving, decrypt it. Okay. Data will be encrypt, data will be decrypt after receiving. So that is called a presentation layer. Session layer. So session layer means it will establish, maintain, terminate, establish, maintain and terminate the session. So what is this session? See, when we start a class, like we started a class, then session is started. We maintain till the time is completed. Once it is completed, we terminate the session. See, here it is. So here is my server. This is my destination, means sorry, source and destination, or you can put a APC, BPC or server client, any name you can put it. So I open a website. For example, this is my web server. This is my web server. Web service is a best example for so many things because we know how to open a website, right? So I open a website from here. Request, send, right? When I'm sending a request, I create a session here. A session ID will be created. A session ID will be created at here. And I send the request to destination. So destination understand the session ID. Okay. So it put a session ID here and understand your request and replying it. Now transaction completed, right? You send a request, you got the information. Transaction completed. Till the time session will be maintained. Transaction must be completed. Like you have a server, means you have a remote PC. You are trying to download a data from it. You're asking, I want to download this data. Now you download the data. Download is completed. Download is completed. Session is done. Session is done. It means when you start communicating, it establishes a session. When it is done, terminate. The meantime, it will maintain the session. Okay. Meantime means establishment to work done. Okay. It will maintain the session. So session layer establish the sessions, maintain the session, terminate the sessions, and also it will maintain multi sessions. Multi sessions it will maintain. Next, remember always any interrupt any interruption or interrupt occurs in network, okay, any interruption occurs in the network, so session will ends, okay, or it terminates. Means, maybe some of you, maybe most of you are experienced this one, this example, like downloading a file. So I download a file. So where we are there? Yeah, here it is. I downloading a file, for example. This is I'm downloading through internet. Internet is disturbed, or wire is disconnected, or Wi-Fi is disconnected. So while it is downloading, like it is around 160 or 170 MB data. Think like I'm a 100 MB data. Downloading 50% completed or 60% completed. Now network is disconnected and terminate the session automatically. You cannot continue the session. You can't continue. See, because network is disturbed, session is ended. You cannot download the remaining data. You have to download it from starting. You have to download it from starting. So that's why uninterrupted internet is must required when you are attending any examinations or sending a data or transactions, payment gateways, payments, like you buy a Amazon something, and while you are selecting things, no problem. Just you went to the cart, you select an items, no problem. You're currently not available. Okay, you're sending an items, and for example, you select this one. Meanwhile, internet is disconnected and connected back. No problem in generally. Okay, in generally, no problem. But if you are okay, when you are purchasing it, like you put a buy option and you are giving like this, you click on a buy option and you are giving a amount details, enter, send all. So that time session is gone, then problem is occurs. So compulsory make sure that a constant internet must be there. I have a very good experience for understanding of the session layer also there. Okay. So we'll explain that one later. So we'll see any interruption occurs in the network also will give the session will be terminate or ends the session. So that is one thing. Okay. So use the download managers for a download things. Like I use free download manager. I use an application called free download manager while downloading. So or internet download managers. So like that it is there. They'll keep the sessions. Torrents also like that. Today you can download a 5%, tomorrow 10%, day after tomorrow 50%. Like that you can download small parts. Okay, because of download managers can able to. But remember, session layer establish, maintain, and terminate the session. Multi sessions. Any interrupts occur, network session will be terminated. Guys, understand session layer or not?
Yeah, sir, understood.
Okay.
Yes, sir, understood.
Transport layer. So it is 1 o'clock already. Transport layer. Okay. So what is this transport layer? So what are the transport layer will do? 3 layers completed, right? So transport layer will do. If possible, I will share some video and as well as the pictures of my world in the evening. I will search and disturb. Okay. Guys, afternoon no session. Okay, some of you already fixed afternoon is no session is there. So once I finish the OSI layer, class will be completed. But you have to study basic things. I will tell what to study compulsory. So Monday, if possibly, I will ask some of you selectively. I will ask the questions from here. Okay, both OSI layer devices, any statement I will ask. Okay, I will share entire information through WhatsApp.
Okay.
Okay, sir.
Transport layer will segment the data. Segment the data. What is segment the data? It means it chops data into small pieces. Yeah, this is correct. So small pieces. Okay, it means, see, look at here. I have a data. For example, this is my common example for explaining this one. Hello, how are you? So this is my data. Okay, this is my data. For example, just for example only. Okay, it is not exact. Okay, say this is my data. So what happened? I divide this data into small parts. I'm using colors for a. Okay, I divide this data into small parts. Why dividing is like this? You can see why need a division, guys. Always communication happens like this. When you are sending a data is sent from one place to another place in different way. Like I'm sending this hello, how are you from A to B. Okay, so when B received a data, it sent an acknowledgement. Okay, when B received a data, B give a acknowledgement data received. Means okay, B is received. No problem, right? When B is received, B send a acknowledgement back. So we can understand B received a data. You send a data, B didn't give you any acknowledgement. No acknowledgement. Meaning is B didn't receive message. Okay, B didn't receive the data. Think like this. I'm sending this entire message, but at B it got like this. Hello, how? That's it only. Not complete message. Not complete message. See, message is not completed. Something is missing. Okay, U is missing. So B think it is a error. It is a error. So it dropped the packet, not giving acknowledgement. So I thought B is not received my message. Again, I will send. There is some other error. B thinks it's an error and it dropped the packet. Again, I will send because B not giving any acknowledgement. I thought B is not received it. I send it. So now it is. How what happened? Very small mistake. And the data is again B think you send a wrong message, wrong data. So obviously drop the packet. So again I have to send it again. Again. So the bigger the size of the file, if small error is there, even the small error we can't able to recover it. Again you have to send it. Again you have to send it. Again you have to send it. Okay, so that is a big problem with sending bigger data. Okay, so what I'm doing is I'm chopping it. I'm chopping the data, and each data I put a number. Just for example, I'm putting a number like this. Just for understanding, guys, the numbers are not like this. Okay, numbers are different. This is for our understanding purpose. What I done, I made a pieces and I send a messages and I put a numbers on it. Okay, so here it is. You look at here. I send a packet. The first one is hello, right? I send a hello, and B received it and send an acknowledgement. So I understand hello received. Then I send a other packet. So I keep sending like this. Okay, and again I send another packet. Again other send a packet. 4 packets, right? 4 packets are sent. First is hello. Next one is how. Second one. Third one is I send R, and fourth one I send U. Okay, so 3, 4. Now I received acknowledgement. First one is already received, so I will put again first one, second one, fourth one. Acknowledgement I received for a 1, 2, 3, 4 only. So at destination, what message is received? Hello, how you? Okay, so you forget R. Okay, so follow. You received a first packet, second packet, and a fourth packet. You're missing something. So think like this. You received a destination received 3 packets. So how many packets you have to send again?
1.
Only one. Only this packet you have to send, right? So I send again third one only. I send only R. Okay, and it received and it sent an acknowledgement. I received a third one. So R is received. Now what is the message? Hello, how you are? Column. Okay, if you are destination is English teacher, then column will occur, right? So English free candidate, English medium candidates. So like a hello, how you are? So what is this meaning? It's like column, right? But no column, because we are putting in numbers and sequencing numbers. Not only just a number, it's a sequencing number. Automatically, it will go to its place only. Once it is completed, then only the message will go to upper layers. Okay, upper layers means session layer, presentation layer, and application layer. So complete data should be assembled at a transport layer only. Okay, it is a segment the data, means chop the data into small pieces. The size of segment means piece, okay, is around 64 bytes to 1500 bytes. Okay, so not less than 64, not more than 1500 bytes. Okay, that is the size of a segment, size of a total segment actually. So less than 1500 data size. Data size is less than 1500. Total is 1500 bytes. Okay, segment data, and of course sequencing, numbering, and sequencing. Numbering and sequencing. So on the data there is a numbers and as well as a sequencing numbers are there, numbering and sequencing is there. So then whenever the destination assembled the data, it is easy to assemble because of numbering and sequencing. So this is about your transport layer. No, not completed. Only one part is completed. There is a very important point is there, that is TCP UDP part. Okay, so what happened at transport layer is one more thing is you use a different protocols. So you use a different protocols. So what it will do, it do like this. it encapsulate, or we can say multiplexes the data like this, etc. TCP UDP. Okay, so already we discussed about a protocols. These protocols, where it is. Okay, already we discussed about a protocols, right? These protocols either TCP type or UDP type of protocols. So it encapsulates all TCP protocols into TCP encapsulation, all type of UDP protocols into UDP type of encapsulations. Okay, very simple. Like I use HTTP for example, and also FTP, and also I use a TFTP, and also I use DNS for example. Okay, so like it will encapsulate in one session. So I use different protocols. So those protocols either TCP type or UDP type, they encapsulate into TCP UDP. Okay, so what is this TCP UDP type? Transmission control protocol, user datagram protocol. So it multiplex and demultiplex the protocols. Okay, so what is this TCP? Transmission control protocol. Transmission control protocol. It is quite easy to copy paste because lack of. There is a lot of explanation regarding TCP and UDP is also there. Okay, compulsory guys, go for if possible, better go once TCP, UDP, acknowledgement, sync, non-sync kind of stuff is there. So compulsory go for it. Okay, so here it is just a basic explanation. I am telling this TCP, UDP kind of stuff. Okay, not depth of explanation. So transmission control protocol. Okay, certain protocols are TCP type protocol, certain protocols are UDP type protocols. Okay, some are both, some are behaves like a both. So remember, like this is certain protocols are TCP type. Example, HTTP, FTP, okay, NTP, like that, SMTP, like this. There's a lot of protocols are there. Okay. Certain protocols are UDP type protocol. Example, UDP type of protocols. Example, TFTP, trivial file transfer protocol, DHCP, DNS, like this. Some are both TCP and UDP. Okay, so remember like this. So that's important one. Okay, so compulsory when you are doing some firewall kind of stuff, you must know the protocol is TCP type of protocol or UDP type of protocol or both. Okay, so that's why that is a very important one. So TCP means transmission control protocol. It is acknowledgement based. It is acknowledgement based protocol. It is no acknowledgement. No acknowledgement. So what is this acknowledgement based protocol? Again, look at here. This is APC, this is BPC. Okay. For example, I send a packet and B received a packet, it will send acknowledgement. And I send a packet, B received a packet, it will send acknowledgement. I send a packet, B not received it, it don't send any acknowledgement. So I can understand B is not received. B is not received. So that is called a acknowledgement based communication. Okay, acknowledgement based communication. Source and destination. From source, you send a packet. Destination received a packet. You send a packet. Destination received a packet. So the destination will send an acknowledgement to you. Okay. Just for understanding, I put arrows. Then later I have to remove the arrows also. Okay. Because so I send a packet. Destination received a packet. It will send a acknowledgement. Send a packet. Destination not received it. It does not send any acknowledgement. No acknowledgement here. Nothing. So what I think, the packet 3 is not received by destination. So I will resend a packet again. So that is a acknowledgement based communication. Here also same, source, destination, but here it is little bit different. I send a packet, destination received it. I send a packet, destination received it. And I send a packet, destination, for example, not received. I send a packet, destination received. Or okay, so but problem is I don't know destination received or not. I don't know destination received or not. Okay, so whether it is received or not, I don't mind. I just send a packet and destination either received or not. So source don't know destination is received or not. Source knows destination received packet or not. Source don't know destination received packet or okay. So that is source knows destination received or not. So this kind of communication we called as a connection oriented protocol. This is a connectionless. Lot of people give an example. Connection oriented means wide network, connectionless means Wi-Fi network. Okay, no, it is completely wrong, guys. This is a complete wrong teaching. It is a wide, okay, this is a wireless or Wi-Fi kind of stuff. It is not at all an example, guys. Connection oriented, it means, For example, I ask a question, you told an answer. Okay, or I told for example, from last 15-20 minutes onwards, no one is speaking anything, right? Even I don't know whether you are connected, disconnected, can you able to hear or not, I don't know, right? Just I keep telling the information, either you received or not, I don't know. So that is called a connectionless communication. Last time I told one examples, right? Like I ask a question, ASCII. I ask a question, what is I ask some questions regarding this OSI layers or port numbers. You given answers, right? So what is OSI layers? What is ISO abbreviations? You given information. So you given interaction. And I ask, do you understand? You said, I understand. It is connection oriented. So I know whether you got the information or not. Very simple WhatsApp messages. So what is the meaning of this check mark? What is the meaning
Received.
of
Received.
it? Means
Everyone see this message.
so I know
Seen.
you seen. Yes. Meaning is destination received a message. So that is I know destination received a packet or seen the packet. So that is connection oriented. Okay. So I send a packet, but I didn't get any kind of a check mark, single check mark or double check mark or blue check marks. Meaning is I don't know whether you are received or not. For example, I send a mails, right? For example, I send mails. So this is send mails. I send mail to the people. I don't know they checked it or not. I don't know if they received or not. So just I send a messages. So like that, it is connectionless. Means you send a packet, you don't know destination received or not. You send a packet, you received an acknowledgement, so then you know destination received a packet. So that type of communication we call as connection oriented and connectionless. Last time in one interview they asked a question, UDP is a connectionless protocol, then how you connect it? Guys, again I'm telling, connected or connectionless does not mean wired or Wi-Fi kind of stuff. Protocol type only. Protocol type only, the way it is communicates. The way, the behavior of the protocol is either connection oriented or connectionless. Connection oriented because of acknowledgement based. Connectionless because of no acknowledgement. So sender don't know destination received or not in a connectionless. Okay. So you done a mistake. Your father starts scolding you. What you do? You don't give any reply. Connectionless. You want money. Connection oriented. So same thing. So again, example already I've written here. Same example. Yeah, it is a reliable. Why it is a reliable? Why it is non-reliable? Because we know data is delivered or not. Okay, reliable because we know data is delivered. That is connection. So example protocols are HTTP. A lot of protocols are there. HTTP, FTP, okay, SMTP, like that. So many are there. Example protocols are exactly say TFTP is the best example. Trivial file transfer protocol. DHCP, DNS actually not a correct examples, but which we know that one only. Okay. So DHCP, DNS, both TCP and UDP type of protocols. You want to know which one is TCP protocol, which one is UDP protocol. So then go to protocol list. Okay. Yeah. So wtschools.in. This is someone is created. This is useless. So you'll get a list, TCP type or UDP type list. See, you can see DNS protocol, TCP type, UDP type, DHCP, UDP type, TFTP, UDP type, HTTP, TCP type. Okay. So protocol list with the port numbers like that you can find in a different websites will give you. Wikipedia also you can try TCP type, UDP type. Okay. So like that. So some protocols TCP type, some protocols UDP type, some are both. Okay, some are both. And also find out the abbreviation of each protocol abbreviation. Okay, so this is about your transport layer, not finished. It's a very big one. Flow control or windowing is another job. Flow control or a windowing is control data transmission speed based on destination. Okay, so guys, for think like this, I have a 100 Mbps NIC, and here I have a 10 Mbps NIC. Okay, it is small, right? This is a small speed. This is high speed. I can send a data with 100 Mbps per second, but here I can receive a data 10 Mbps per second. So for example, I send a 80 MB data. 80 MB data I send, but I cannot receive. I can receive only 10 MB. So 70 MB cannot able to receive. So right, sometimes it is a problem will occurs. Whenever the speed is matches, this mismatches in a different scenarios, like not only 100 Mbps and 10 Mbps, also both side 100 Mbps. Also, it cannot receive that 80 MB data at a time because of other traffic also there, no? Maybe CPC also sending message to be, maybe DPC is sending a message to be. So a lot of traffic is there at one single point. So it cannot receive the data at all the time. So right. So what we do, we estimate the speed of data delivery. So then we can send a data. So that is called a flow control or windowing. What is flow control or windowing? So based on the destination, how much data can received by destination at this time. Destination, how much data or a number of packets, exactly say number of packets at a time. So we don't send a packets one by one, actually at a time means bunch of packets we'll send it. Okay, number of packets at a time. So received by destination. Okay, so that is, so based on that we provided. Okay, we'll give it things. At this time, time to time the destination capacity changes. So we have to estimate it and then based on that send a data. Based on information, so based on it send packets and like that you can see. So to understand this one, number of packets, the destination, how much it is received, we can able to do it. It is 1:35 guys. I have to finish. I'm getting Okay, so guys, remember this one. One more point is there, that is called a PDU. PDU means packet data unit. There is a no name. It's a common name for any data. Okay, packet data unit. Packet data unit is any data from the any layer of the data is called a packet data unit. But here it is in the transport layer. What happens? Data is segmented and added with some sequencing numbering. Okay, and also adding with a TCP header. TCP header added to your data. Okay, the data we call it as a PDU. This totally we call it as a segment. Okay, this PDU we call it as a segment. What is this TCP header contains? About a TCP UDP protocols information, segment information. Segmenting means the numbering and sequence of that segment. Numbering and sequence of the segment. Information stores in TCP header only. What is a PDU? It's just a data. So what are the data from upper layers? Okay. What is the data from the upper layers? So ASCII format, encrypted format, whatever it is, it's a data only. So that is called, we call each layer data, we call it as a PDU only. So data is TCP header is added to PDU, the total we call it as a segment. The segment means that PDU is sent to network layer. I will go to network layer, guys. I will finish in 15 minutes maximum. Okay, so only 3 layers are left, but study all the layers. Network layer, what happened in network layer? It add routing protocols and routed protocols. What is this routing protocols? Routing protocols will tell you how to reach destination, best path selection, like a router. Okay, this information will add it. So in a routing, there is a static routing and dynamic routing. In the dynamic routing, we use routing protocols. Okay, what are the general routing protocols we use? RIP, EIG, RP, OSPF, of course, BGP, IS. Okay. Intermediate system, border gateway protocol. These are exterior gateway protocols. These are interior gateway protocols. Okay. So don't worry what it is, but just go for with the flow. That's it. Okay. But important is RIP, EIGRP, OSPF is an interior gateway protocol. Okay. And exterior gateway protocols are BGP and IIS protocols. So our internet works based on these protocols only. Okay. Dynamic routing protocols. Okay. In dynamic routing we use a routing protocols like a RIP, EIGRP, OSPF. It will tell you how to reach the destination but directly. Static means we define manually, we'll define the routing path. Okay, so these are the about routing protocols. So one part. Next one is routed protocols. What is this routed protocols? Is nothing but IP addresses. Okay, IP addresses, IPX, SPX, Apple Talk. People are even we don't know what is this, but in a test book they are keep mentioning that one. So my point is IP addresses, IPv4 and IPv6. Either IPv4 or IPv6 or both will be there. So either or IPv6. Okay. And IPv4, IPv6, IP addresses, SPS addressing IPX, SPX, Apple Talk. Okay, because of textbook kind of stuff, I have to put it. Okay, next is netware. Novel netware use this kind of stuff. Novel netware use this SPX kind of stuff. Okay, IBM use SPX kind of stuff. So verify these things. Okay, this is not mine. Okay, so routed protocols. So here it is. When you are communicating, guys, compulsory communication protocols is like a post office related one only. So when you are writing a letter, there is a to address and from address. There is a to address and from address, right? So here we call it as a to address is a destination, from address is source. So compulsory you have to require source address, destination address. Here it is, source IP address and destination IP address added to PDU packet data unit. What is our PDU? Is a segment, because the segment is sent to us, right? The segment, that is our PDU here. Okay, so like it is source IP and destination IP address plus our segment. Our segment is our PDU. So this is called originally packet. The packet means source IP, destination IP, and our segment. Segment means our PDU. Okay, this is called a this part we call it as a network header. This part we call it as a network header. So always is written like this. It's a network header. Okay. Network header. Want to write what is this? NH means network header. Meaning is source IP plus destination IP is your network header is added to your segment, and finally you got a packet. The packet sent to data link layer. Now we'll go to the data link layer. Guys, study compulsory. So once you study, you will get lot of doubts, lot of confusion. Then you can ask me again. So then we can discuss it. The data link layer having a mainly two layers. It is divided into two layers. One is LLC, another one is a MAC layer. LLC means logic link control. Our upper layers are software layers, IP address layers and all. But bottom layers are hardware layers like NICs, your hubs, switches, direct communication layers, right? So there is a barrier between the connection between the bottom hardware layers to upper hardware and software layers. There is a barrier. So this link logical controls also will take care of that one. Means network layer to data link and physical layer communication also based on the logical link control, logical or logic link control. You can put a LLC data link layer, logical link control. PDU is also called as protocol data unit, also you can say. Don't get confused. So what is this contains? Okay, so PPP, SDLC, frame relays, and MPLS. Like this, there is so many other protocols are there. Okay, it is a WAN protocols in the link logical control. So when you are communicating in the LAN, so you can communicate with the PPP, SDLC, frame relay kind of stuff. So usually PPP is a point-to-point protocol, serial communication. Okay, WAN protocol it is. There is another protocol called a PPP OE. Meaning is point-to-point protocol over Ethernet. Example is when you take internet from ACT, U broadband, or any local. They will give you from their point to a Ethernet cable directly. Ethernet cable, like I am using Gazon or a Xeon or something. That's a name is spelling is ZON. Okay, in Pune, I am using this internet service provider. They're also giving directly a wire cable, like a direct Ethernet cable. We are using directly is giving. Okay, so are any local ISPs. Okay, so they provide direct wire to us, not direct PPP connection. It is over Ethernet. They are providing internet services. Over Ethernet, they are providing internet services. That's their routers are PPP routers, but their connection is over Ethernet connection they are providing. Okay, that is called a PPP OE. SDLC for router to router communication. Frame relay, some organization use for a WAN communication within that organization. MPLS is a new technology for providing internet services. Not only that one, so ADSL, DSL type of connections also will be there. Okay, DSL or ADSL kind of stuff. Already I given a name earlier. Okay, digital subscriber line, asymmetric digital subscriber line. These are also will in a LLCs. It's a WAN related protocols. When you need a WAN connectivity, you have to follow these connections. Compulsory check this PPP OE, SDL, ADSL or DLS kind of stuff. Okay, and also you know MAC address. What is MAC? Media
Access control.
Very good, you didn't forget. So media access control. So how many bits?
48 bits.
48 bits.
And
12 hexa.
in hexa?
12 hexa.
12 hexa, very good. Okay, 12 in hexa means given by manufacturer. So no need to write all the things, I think so. Given by manufacturer of NIC. Okay, otherwise I will write given by manufacturer of NIC. Okay, So how it is look like? It is examples. I'm writing 45 D3. Anything you can put it, no problem. A B C D must be there. Not there also, no problem. So 12 hexa must be there. That's it. This is it can be there. Okay. There's a broadcast. MAC address is also there. That is a FF, like this. 12 Fs. Important one is it is physical address, and we know how to check it. Get MAC or IP config. Already we are know on this one, right? So that is enough for a MAC address. Yeah, here it is. Two things will be added to our PDU. So one is a data header. This will be added to our PDU, means our packet, and data tail will be added. So data header means source MAC address plus destination MAC address. Data tail means CRC will be added. Okay, CRC will be added. Data header means source MAC address, destination MAC address. Data tail is a CRC. Again CRC. Cyclic redundancy check. What is CRC? Cyclic redundancy check. Yeah, this is the one. It is an algorithm. It is nothing but a algorithm to check errors. It is used to find errors. In data. Okay, error finding and error correction. So important is error finding and correction. Error finding and error correction is possible with a CRC. CRC is also very important, guys. Compulsory remember CRC, cyclic redundancy check. It is an algorithm to verify data is corrupted or safe. Is it to verify data is verify the data. To verify the data, is it safe or corrupted? So like this is the use of CRC. And some people will tell like a transport layer. Where is the transport layer? It is gone somewhere. Okay, a transport layer also will do like a error correction. Why they will tell error correction? Because of the sequencing and numbering. Okay, so that is because of sequencing and numbering. Error correction is possible in a transport layer, with a transport layer, because of sequence and numbering. Because already I explained, if one of the packet is not received to the destination not sending acknowledgement. You don't receive acknowledgement, then you send a packet again. So that is error correction kind of stuff. But this is different. This is, it will verify the data. Each data packet is correct or corrupt. Is correct or corrupt will by CRC only. So your data header and a PDU is added like this. The resultant, we call it as a frame. We call it as a frame. Okay. So the frame sent to last layer, physical layer. Now we'll go to the physical layer. Like, oh, it's 2 o'clock. What is physical layer? So it converts frame into bit stream. What is bit stream? 0 and 0 and 1 and vice versa, means bit stream to frame and it is received. So both the things it will do. Okay. So what it is? So converts frame into bit stream into frame. Okay. And based on interface, or we can say NIC or LAN card or whatever this based on interface or NIC, so it converts into signal. Okay, so what type of signals are there? Type of signals, one is electrical signal. So if you are using Ethernet type, generally Ethernet, UTP, STP, Ethernets, NICs. Okay, maybe it is light wave. If you are using a fiber channel, radio waves, you are using a Wi-Fi kind of stuff, or Wi-Fi wireless. So common name they put a wireless, Bluetooth. I don't prefer Bluetooth. Okay, kind of stuff. Okay, so whatever it is, the bit stream is converted into electrical signal or light signal or a radio waves. So it depends upon what type of NIC we use it. So this is a bit stream. Guys, last point here, no, not required. Yeah, device wise. Okay, device wise. So we have to layer 1, 2, 3, 4. First one is layer 3. What is layer 3? Network layer. Layer 2, data link layer.
Data line.
Layer 3, layer 1, physical layer. Very good. Okay. So again, devices, router, data link, switch. That's why switch can understand MAC address. Physical layer, hub. Okay. So this is about your thing. Actually, there is a comparison between application layer, OSI layer and a TCP/IP layer. Comparison is also there. Transmission control protocol, internet protocol. Okay, TCP/IP, and also earlier we call this one as a DoD model. This is also called as DoD model because it's earlier in the defense they use this model. So in our OSI layer we have a application layer, presentation layer. You can also tell, no problem. Transport.
Network layer, data link
Layer, and physical layer.
Physical layer.
So this application layer, presentation layer, session layer, these three layers combinedly application layer in the TCP IP. Okay, that's why I'm giving a little gaps here. See, transport layer is transport layer, so no change. Transport layer is transport layer only. Network layer we call it as the internet layer because IP addresses we are giving. That's it is internet layer. Physical layer and this one is we call it as a network access layer. Okay, so some people will ask a question like as NIC is belongs to physical layer or data link layer. It's a combination, network access layer. Okay, physical layer as well as a data link layer. Okay, NIC is a physical layer and data link layer combinations. Okay, TCP IP application layer means application, presentation, session. Three duties will be one single layer. Transport is transport. Transport. Okay, network layer here is a internet layer, data link layer is a physical layer. Guys, sometimes it is different from these two. Last two are different from one website to another website kind of stuff. I given a standard one. Okay, CompSci N plus standard or a Cisco standard one only I given. Okay, so some people will look at a Google search and they'll get a doubt, sir. You told differently, it is differently. Okay, so confirmly I will tell few things. Okay, no, few things I will tell verify. Then you can verify that one. Few things I said confirmly. This one it means why I said like this also. I will tell a reason from which source I told. Okay, so this is a comparison only, guys. Lot of people think TCP layer came from OSI layer. No, TCP layer is 1960s. OSI layer is 1980s. Okay, so that is that much of delay time is there. All okay. So I think TCP layer is 1970s, OSI layer is 1980s, DoD model is 1960s. Same DoD model we are using TCP model nowadays. We are using TCP IP model only. We don't use OSI layer for a troubleshooting purpose only. Next one is I told troubleshooting purpose. What is the troubleshooting purpose? One example I will tell, then it is you can try to understand. If you don't understand, ask me on Monday, so definitely I will explain it. Okay, guys, I'm sending a message. This is my client PC, this is my server. For example, this is the web server. I'm asking a website. So first is application layer, so web browser. There I put a HTTP. Okay, HTTP. So website, application layer. HTTPS means compression, encryption. S means encryption will be there. Okay, session will be established. Transport, check it which protocol you are using and all protocols into the thing and segmenting and all. Next one is networking, IP address, source IP, destination IP, source IP, destination IP address. Data link layer, source MAC address, destination MAC address. Physical layer, the connection. Now request send to the physical layer. Physical layer received and convert into frame and verify the MAC addresses, source and destinations. Network layer get the packet from the data link layer and verify the source IP and destination IP address. Transport layer check that which protocol you got it and as well as rearranging the segments and packets kind of stuff, right? So understand the session ID, decrypt the data, decompress the data, okay, like that. And application layer finally got the what kind of request it is. Okay, HTTP request or HTTPS request, FTP request, SSH request. And finally, it is received request. Again, server is sending reply, right? Again, how it is reply? Again, first application layer, web server, application layer, what data it is, compress the data, encrypt the data, okay, encode the data. Again, re-establish session. So continue the session or recreate the new session. Transport layer, segment the data, TCP type of protocol, UDP protocol, rearranging IP address, source and destination kind of stuff, source and destination MAC addresses, and convert into finally bitstream, physical layer, and physical to physical communication. Again, data, again, verify the MAC addresses, okay, frames, MAC addresses, and verify the source and destination IP addresses, packets. Segment, verify the segment sequencing, numbering, rearranging it, verify the session IDs, session is still there or not completed session, terminate the session or still maintain the session, okay, decode the data, decrypt the data, decompress the data, finally reach the destination and display the page. So this is how it is communication happens. Any problem occurs, but how to troubleshoot it? Problem is occurred. For example, you send a packet, destination not reached. There is a possibility is the physical layer is not there, means disconnected. Server is disconnected or a client is disconnected, network is disconnected. Physical connection problem or IP address problem. First is physical connection problem, most possible physically disconnected. Next one is network layer, IP address wrong IP address, okay, IP address wrong, physical disconnection, IP address wrong, okay, server is wrong, application layer problem, server is wrong, so that is not exactly your server. This is not a web server, it is a FTP server or a SMTP server, okay, different server it is, or maybe it is not any server, it's just a machine. Okay, application layer volume, okay, application, so like server is down or maybe service is down, possible. Encryption related issues, you put a HTTP but website is HTTPS website, okay, website is HTTPS website. You put a telnet but server is SSH server. You put a FTP but server is vsftp, okay. So encryption problem possible, right? You put a SSL encryption but server is TLS, one more is there, TSL, TLS or sorry, not TLS, TLS type of encryption, not SSL encryption, okay. So it is presentation layer problem. Session will be broke sometimes. I told one example, right? I didn't told, but I will tell that example anyway. My real-time experience, really it is happened to me. Then I understand session layer power. Okay. Okay, so that's I will explain because we don't have a time now. Okay, guys, verify based on your issue. Either it is physically disconnected, maybe IP address wrong, maybe it is not a correct server, or maybe server is down, maybe there is a problem with the presentation layer. Like that, you can understand the issue based on the you got an issue, you can troubleshoot with that particular layer. Okay, so in the layer wise, you can understand so where the issue is there, and based on that one, you can able to troubleshoot it. So that is a OSI layer troubleshooting. This is overall your OSI layers completed. Okay. So meet you on Monday morning again. So take rest, study well.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Okay,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Right.